Hello students, this is Ms. Heilman and this is the Factoring Polynomials Review PowerPoint. It's going to be a little bit longer than what we did in class because I have more examples that you can stop the video and try on your own. And specifically we're going to talk about the greatest common factor, which should be review, and guess and check, which also should be review. The only thing that's maybe new is the AC method, but it's my personal favorite because it always works to factor a polynomial. Okay, so the first step in factoring is going to be to check if there's a greatest common factor. And this is always going to be your first step because it'll make something that looks really ugly or something that has a really big numbers or a lot of variables a whole lot easier to work with. So for example, if we have 15x to the fourth plus 40x cubed minus 10x squared, we want to look for both a numerical and a variable common factor. So the numbers, the constants from our terms are 15, 40, and 10. And we're not going to worry about this negative right now. We just want to look for the factors. And if you remember the factors, we want to look for things that multiply together to get a certain number. So what numbers multiply together to get 15? So we're always going to start with 1 and the number itself, because I can multiply 1 times 15 to get 15. 2 times, well, nothing evenly will go into 15. Alright, 3 and 5, that'll work. And that's it. So if you think about it, we would go to the next highest number, which would be 4. 4 times nothing even is going to be 15. And then we get back to 5. So we've kind of reached the other side. There are no numbers that we can use as a factor. Alright, for 40, we have 1 and 40. We're going to go move on from 1 to 2. 40 divided by 2 goes in evenly 2 and 20. And then 40, let's see, 3. 3 doesn't work, so we would do 40 by 3, we get a decimal. Alright, 4 and 10. And 5 and 8. And 6 and 7 don't work, so we've reached the other side. We're done. Alright, 10, 1 and 10. Move on to the next highest number, 2 and 5. 3 doesn't work, 4 doesn't work, and we've reached the other side, so we're done. So looking at these lists of factors, we want to find the highest one that they have in common. So that's literally what greatest common factor means. Greatest means the biggest one, common, that they all have, and it's a factor, a number we multiplied to get. So the greatest common factor of all these numbers is going to be 5. Now, I know we have this 10 for both 40 and 10, but we don't have a 10, 15. Or, I'm sorry, we don't have a 10 in 15. It has to be a common factor, so that means it has to go for every single term. Otherwise, we can't use it. So we have to use 5. So we know that part of our greatest common factor is going to be 5. Now let's talk about the variables. So for our variables, we have x to the fourth, x cubed, and x squared. Sorry, my 3 is a little messed up. So if you remember from your variables, if we have x to the fourth power, the reason this is to the 4 is because it's really x times x times x times x. There are 4 x's, but instead of writing all of this out, we just write x to the fourth power. And x cubed is x times x times x. X squared is x times x. So the same way we were looking for a common factor, here we're looking for how many of these x's, how many of the variables do they have in common. And each of them have at least 2 of the x's. So that means we're going to take out an x squared. So our greatest common factor is 5x squared. That's the most that these 3 terms have in common. And now we're going to rewrite this by taking out the 5x squared and writing it out in front and leaving behind what isn't common. So if we have 15x to the fourth, you can either think of this as 5 times what is 15, or think about 15 divided by 5. Either way, it's 3. That's what's left over. X to the fourth divided by x squared, or how many x's did we take out? We took out 2, so that means there's 2 left. And in our illustration, we can see there's 2 left. And the 40 divided by 5 is going to be 8. And if you notice on my factors, I've listed them like this, so it kind of tells me what numbers are going to be left over. We have 3 x's here. We take 2 away. There's 1 left. And then this is where we're going to put our negative sign back in. We weren't worried about it over here because it's already going to be written again. Minus 2, and then x squared, there were already 2, so that's it. So this is the factored form of this expression. Remember, factor means to write something as its product. So what numbers did we multiply together to get this expression? We multiplied this together to get that. So we have factored. Alright, go ahead and pause the video and try this problem on your own. Okay, so we first want to get a common factor. We have 2, 18, and 36. And 2 is going to be our big clue because 2 is a prime number. If we think about our factors of 2, all we've got is 1 and 2. So we just need to check whether 2 is a factor of these 2. Otherwise, it's going to be 1, and that doesn't really have a whole lot of meaning for us. So 18 divided by 2 is 9. 16 divided by 2 is 18. So that means it will work. So our common factor numerically is 2. Now let's look at our variables. We have a v squared, a v, and no v. Remember, our common factor needs to be something they all have in common, and this 36 doesn't have a v. So that means we can't take a v out of all of them. So our factor is going to be 2, and we're left with v squared. Notice it's a 1, but we don't really write the 1. We just put v squared. Minus 9v minus 18. That is the factored form of this expression. Alright, for this one we have 3x squared plus 9x. So we're once again going to look for the numerical greatest common factor. We have 3 and 9, and 3 is prime, so we can only multiply 1 times 3. So we want to figure out whether 9 is divisible by 3. We do 9 by 3. It's 3, which is the it goes in evenly. So that means we can take a 3 out. And we have an x squared term and an x term. So they at least have one x in common. So our greatest common factor is 3x. And we're going to rewrite what's left behind in the parentheses. So if we take out a 3x, or think about this as dividing by 3x. Or you can think about 3x times what is 3x squared? Just an x. And then 3x times what is 9x? That's a 3. So this is the factored form. Go ahead and pause the video and try this one on your own, please. Alright, our common factor. Let's look at 4. It's 1 and 4, and we have 2 and 2. 28. We have 1 and 28. 2 and 14. 3 doesn't work. 4 and 7. So the highest one that they have in common is this 4. And we have x squared and an x. That means they at least have one x in common. So 4x is going to be our greatest common factor. And we're going to have an x left here. And we're going to have a 7 left here. Notice they only had one x, so we took one out. There's none left. Okay, this one may look a little scary, but I guarantee you know how to do it, I promise. So, the rectangle below has an area of 14x to the 4th plus 6x squared. The width of the rectangle is equal to the greatest common factor of 14x to the 4th and 6x squared. What is the length and width of the rectangle? If this is our area, that means they multiply the width times the length to get it. And the greatest monomial factor is the width. So all they're asking us to do is find the greatest common factor. Greatest common factor of this is going to be the width, and then what's left over is going to be the length, because they multiplied them together to get the area. So let's look at 14x to the 4th plus 6x squared. if we do 14 and 6, their greatest numerical factor is going to be a 2. 2 times 7 is 14, 2 times 3 is 6. And this has x to the 4th power, this has x squared, so we can take n squared out. Now our width is going to be our greatest common factor. That's going to be 2x squared, what we just figured out. And what's left is going to be our length. So let's figure out what's left. 2x squared. Think about what we would multiply what we would multiply 2x squared by to get 14x to the 4th. We'd multiply 7x squared, and then this x squared is going to go away, but then we'd have 3, so our length is going to be 7x squared plus 3. Alright, so let's move on to some more complicated factoring of polynomials, and specifically we're going to talk about quadratic expressions, and this is the form of a quadratic expression. This is supposed to be an a, so it's ax squared plus bx plus c, and we use a, b, and c in a very specific way here. The a is the constant or the number in front of the x squared term or the squared term, because it's not always going to be x, and then the b is the number in front of the x term, and then the c is the constant. And when we're factoring polynomials, if we have this trinomial, that means they multiplied a binomial times a bimonomial in order to get it. So there was a plus or minus sign in here, and then there was some term in the front, and then some term in the back, and that's usually how they get this trinomial. So in general, we want to find factors of the product AC, because if you remember, in order to get from this binomial to this trinomial, they had to FOIL. So first, outer, inner, last. So they need products of AC. So we want things that multiply together to get AC, that'll add or subtract to get B, that middle term. And I know this is a little complicated, but let's go over some of the things you've seen before, like guess and check. So if we have something like x squared plus 3x minus 10, we want to factor that completely. And the way we're going to do that is by writing a binomial times a binomial. We just need to figure out what goes in the binomials. And I have a kind of chart thing up here that's going to help us figure out our signs. So if you notice, the first trinomial we have has a plus sign and a plus sign. So in order to get that trinomial, the two binomials they multiplied together had to have plus signs in between. If we have a negative first and then a plus sign, that means that both of them have to be negative. Because the only way that you're going to get a positive last term, if the first term is negative or the middle term is negative, is if you multiply a negative times a negative, which gives you a positive. And if the last term, if the constant is negative, and then it doesn't matter if it's a plus or minus sign in front, that means one of them was positive and one of them was negative. So if we look at our example here, we have a plus and then a minus. So if we look, okay, plus up front, minus, oh, that doesn't work, plus, oh, that doesn't work, plus and a minus, that means one of them had to be plus and the other one had to be minus. So I'm just going to randomly assign them. So I'm just going to put plus first and a minus second. You could do this with a minus first and a plus second. Doesn't matter until we put the number of values in there, and then it will matter. Alright, in order to get this x squared, remember our first terms, we're going to FOIL them. So you'd have to do this term times this term to get x squared. The way we do that is by putting an x, because if you multiply x times x, you get x squared. So we've taken care of our first term. And remember, we wanted, for guess and check, things that would multiply to get AC. So A is 1, C is 10. So what are the factors of 10? So what can we multiply together to get 10? 1 and 10, 2 and 5. Now do any of these add or subtract to get 3? Yeah, we have 2 and 5. So this is the guess part of it. Now notice we did an educated guess. We're not just going to plug in 1 and 10. We're not going to plug in random numbers. We're looking for numbers that multiply together to get 10, that are add or subtract to get 3. And we're going to pick 2 and 5. So I'm just going to guess now. And I'm going to put 2 first and then 5. And the part that people sometimes forget is that you need to check. That's part of the guess and check. So we're going to check that by foiling. So if we do x times x, we get x squared. X times negative 5 is negative 5x. 2 times x is 2x. 2 times negative 5 is negative 10. And then when we add these all together, combine like terms, negative 3x minus 10, we do not get to our original. Remember, the original had a positive 3x, so this doesn't work. So we guessed, but our check revealed that this is not the correct answer. However, it did reveal that we had it the opposite sign. So we had a 3, we just had a negative 3. So that's going to let me know that I need to flip the 2 and the 5. So let's flip that 2 and 5. Let's put 5 positive and 2 negative. And if you noticed, when we FOILed, we did the first and we got x squared, and we did the last and we got negative 10. Well, yeah, because we picked numbers that would specifically get us that. So we really only need to worry about the middle terms. So we can do that, and in order to help kids remember it, it kind of makes like a little face. So there's the nose, and there's like the little tongue, and these are like its glasses. If that helps at all, if it disturbs you, I'm sorry. But we just want to worry about the middle terms, because those are what we're trying to match here. We get 5x, and then we get negative 2x. If we combine those, we get a positive 3x, which lets us know we guessed, and then we checked it, it checked. So this is the factored form of this expression. We multiplied these two binomials together to get this trinomial. Alright, so for this problem, we're going to start out by trying to find a greatest common factor. We have 1, 14, and 48. The greatest common factor is 1, and that's not meaningful for us, so we don't have a numerical factor. Alright, we have m squared m and no m. That means there isn't any greatest common factor for the variable, so we're just going to factor it now using guess and check. So we know it's a binomial times a binomial. The first term is going to be m, and then our last term is going to multiply to get 48. So let's think about factors of 48. We have 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. So do any of these factors of 48 add or subtract to get 14? Yeah, 6 and 8. So we know it's going to be 6 and 8. Oh, and I forgot to do my signs. But we have a negative first and then a positive, so that means these are both going to be negative. And that makes sense, because if they multiply the last one, be negative 6 times negative 8, be positive 48. And what's really great about having the same signs is that we're done. We can check it, but we don't have to switch anything around. So m times m is m squared. M is negative 8m, negative 6m, and 48. We get m squared minus 14m plus 48. Yay, that works. So our final answer is the quantity m minus 6 times the quantity m minus 8. So go ahead and pause the video and try this one on your own. Okay, so we're looking for a common factor, 1, 8, and 12. We don't have a numerical common factor. We have x squared x and no variable common factor, so we're just going to do regular factorization. So x squared, we're going to have an x out front, and we have a negative and then a positive, so that means these are going to both be negative. And we're going to look for things that multiply to get 12 that'll add or subtract to get 8. So we have 1 and 12, 2 and 6, 3 and 4. And if we do 2 and 6, that'll add together to get 8. So 2 and 6, and we can check it by doing negative 2x and negative 6x. That indeed gives us negative 8x, so this is the factored form. Alright, for this one, let's do our same procedure. We're going to check for greatest common factor. We have 3, 30, and 63. So 3 is a prime number, so it would be really great if we could divide both of these by 3. So if I check 30 divided by 3, 63 divided by 3, those both work. So I can take out a 3, and I have n squared n and no n. So that means I can't take any variables out, but I can take out a 3. So when I take out that 3, I'm left with n squared minus 10n, because 30 divided by 3 is 10. And then 63 divided by 3 is 21. Okay, so I want the fully factored form of this. So that means we're going to leave this 3 out here, but I kind of want to make sure that it doesn't mess with any of the stuff that I'm going to do. So I'm going to rewrite it outside of the parentheses and just make sure that I keep it separate from what I'm about to do, because I'm about to do the binomial, but I'm going to be factoring just the n squared minus 10n plus 21. So kind of ignore the 3 for right now, because we just want to factor this. Remember, the point of taking out a greatest common factor is to make it easier to work with. So by taking out the 3, we don't have to deal with quite such big numbers. So let's look for factors of 21. Oh, first let's put n's. And we have negative and a positive, so that means these are both going to be negative. And we want factors of 21. So 1 and 21. 2 doesn't work, 3 works, 4 doesn't work, 5 doesn't work, 6, and we're back over here. So, do any of these add to 10? Yep, 3 and 7 do. And we can check by doing the middle terms. Remember, we're kind of going to ignore this 3 because we're just going to check for this trinomial. So negative 3n and negative 7n gives us negative 10n. That'll work. The fully factored form is going to include the 3 that we took out, that's greatest common factor, and the 2 binomial factors we just found. That is the fully factored form of this. So if we multiplied this back, we would get back to our original expression. And that's kind of the point. Okay, go ahead and pause the video and try this one on your own, please. Alright, for 5, 40, and 75, we have a common factor of 5, and there's no p here, so that means we can't take out a variable, so we can rewrite this as p squared minus 8p plus 15. And then we're going to factor the trinomial inside of the parentheses. So it's going to be 5 times p, and we have a negative and then a positive, so these are going to both be negative. And we want factors of 15. So 1 and 15, and 3 and 5, and that's it. 3 and 5 will add up to get 8. And I can check it. And get negative 3p and negative 5p. That gives me negative 8p. That'll work. So the fully factored form is 5 times the quantity p minus 3 times the quantity p minus 5. Okay, this one's going to be a little bit different, but let's approach it like we normally would. So let's look for a greatest common factor. We have 2, 9, and 9. So 2 and 9, it's kind of convenient because they only have to do 9 once. 1 and 9, and 3 and 3. So we don't have any greatest common factor. The greatest common factor is 1, and that doesn't really help us. It's not really meaningful. So we can't take out a number. We have v squared v and no v. We can't take out a letter. So we just have 2v squared plus 9v plus 9. But we're still going to want to factor it because I'm pretty sure this trinomial can turn into a binomial times a binomial. So the problem with this one is this 2 out in front. Because before, when we had something like v squared, we could put a v on each side, and it didn't matter because we had a 1 in front of this v. But now, we have a 2v and a 1v. That's the only way we could get 2v squared. And the problem is that when we FOIL this, it's going to matter. One of these gets multiplied by 2, and one of them gets multiplied by 1. So we could do guess and check, but guess and check with this is going to be really long because there's lots of different options. So we need a different option, and that's where we come in with the AC method. So the reason it's called the AC method is because it uses the A and C value of our quadratic. So remember, our quadratic trinomials have numbers attached to the letters A, B, and C. So A is the number or constant in front of the squared term, B is the number in front of the term to the first power, and C is the constant. And it's called the AC method because we're going to use the A and C value. And what we're going to do is we're going to multiply them together because, remember, when we FOIL, these last two get multiplied together. So we want to look for things that will multiply together to get that factor of A and C. So if we do 2 times 9, we get 18. And we want to look for factors of 18. So 1 and 18, 2 and 9, 3 and 6. Okay, so I wrote this out as a binomial times a binomial, and it will eventually be that. But this is how we solve stuff for guess and check. So for AC method, we're going to do something a little bit different. So we're going to expand our middle term. And expand just means we're going to make something a little bit longer. And we're going to make it longer to make it shorter in the end. So we're going to rewrite this 9v using one of these sets of factors. So do any of these sets of factors add or subtract to get 9? So if I did 18 minus 1 and 17, that doesn't work. 18 plus 1, 19 doesn't work. All right, 9 plus 2 is 11, doesn't work. 9 minus 2, yep, that doesn't work either, that's 11. All right, 6 plus 3. All right, that'll work, that'll give us a positive 9. That'll work. So we're going to expand the middle term, and we need to get these to be equal to a positive 9v. So the way we would do this is these are both going to be 3v and then 6v, and you need to have both of them be positive if the 9v is positive. So think plus 3v plus 6v. If we did negative 3v plus 6v, we'd get 3v, and that isn't what we want. We want to make sure our signs match. So we're going to rewrite it as plus 3v plus 6v, and then we're going to bring 9 down again. So I have expanded the middle term. If I simplified this, I would get back to 9v. I haven't changed the value of the expression. All I've changed it is just to make it a little bit easier to work with. All right, next what we're going to do is called factoring by grouping. Basically, you're going to figure out what do the first two terms have in common and what do the last two terms have in common. So once again, I'm going to look for a greatest common factor. We have a 2 and a 3. There's no number that they have in common except for 1. But they do both have a v in them. So I can take a v out. That's my greatest common factor. And what I'm left with is going to be 2v plus 3. So I'm going to write that out like I normally would. And then my plus sign comes down. And what number can I take out of both 6v and 9? So I can't take out a v, but I can take out a 3 from both of those numbers. And I'm left with 2v plus 3. Now, if you've done this correctly, if you've picked the right numbers here, you should notice that the things in parentheses are the exact same, and that's kind of the point. The idea is if the v has this in common and the 3 has this in common, we can take the 2v plus 3 out, and we're left with v plus 3, which is the factored form of the original expression. So once again, the AC method is called AC because we're going to multiply the A times the C because we want to look for factors that'll make this, this 18. And then we look for one that'll add or subtract to get the middle term. We expand the middle term here. And then we factor by grouping. So we find a common factor for the first two, common factor for the second two. And then the factors, if we've done it correctly, should be the same. Then we take those out and rewrite what's left. And if we multiply this back out, so 2v times v is 2v squared, 2v times 3 is 6v, 3v times v is 3v, and 3 times 3 is 9. We get back to our original expression. Alright, so let's do another one together because I know that was kind of a lot. Alright, so let's look for a greatest common factor first. We have 2, 25, and 50. And 2 would be great if we could divide these both by 50, or by 2. This one will work. 25 divided by 2 is not even, so it doesn't work. So we can't take out a number. Can we take out a letter? No, because there's no m in the constant term. So no greatest common factor. So let's use the AC method because we have a 2 here. So we know it's eventually going to be a binomial times a binomial, but my guess and check is going to get really weird if I don't do the AC method. So we're going to do 2 times 50, which is 100. Alright, and we want to look for factors of 100. Now I know this seems like a big old number and we have lots of factors, but remember we're only looking for a set that'll add or subtract 25. So once we do that, it should be shorter. Alright, let's do 2 and 50. And if you are having trouble with the factors, you can either put into Google factors of 100 and it'll actually give you the list of factors, or you can do this in your calculator. Do 100 divided by 2, 100 divided by 3. 3 isn't going to go in evenly, so we're not going to write that down. 100 divided by 4, which is 25. 100 divided by 5, which is 20. 6, 7, 8, 9, 10, and 10. And we've reached the other side, so we're done. Alright, so we need to find which of these will add or subtract to get 25. And this pair does. And notice we want a negative 25 here. How am I going to get this 5m and 20m to then be a negative 25m? The only way that would happen is if they are both negative. So when I expand the term, I'm going to bring down the first and last term, but I'm going to expand this middle term by putting negative 5m minus 20m plus 50. So I've expanded the middle term. I haven't changed it. Changed its value. I've just rewritten it so it's going to be easier for me to factor by grouping. And notice if I wanted to, I could get back to the original equation, or the original expression. Now I'm going to factor by grouping. So what common factor can I take out of the first two? What common factor can I take out of the second two? Oh, and I'm going to make this a plus negative 20 just to make my life a little bit easier. Okay, so if we have a 2m squared and a negative 5m, we can't take anything out of both 2 and 5, but we can take an m out of both of them, and we'd be left with 2m minus 5. And this is the tricky bit. Notice that we want to have the same thing in parentheses over here as we do in the front. So the only way that we're going to have a positive 2m if we start out with a negative 20m is if we take out a negative number. So if we take out a negative number, that's going to make this term positive and this term negative, which will hopefully get us to 2m minus 5. And if you're having trouble figuring out the greatest common factor for this, remember it wants to be the same as this in parentheses. So think about, what did you multiply by 2m to get negative 20n? You did a negative 10. And what you're left over with is 2m minus 5. Notice the things in parentheses are the same, so we can put those out in front because they both have those in common. And what's left? M minus 10. So that is the factored form of this expression. Okay, go ahead and pause the video and try this one using the AC method, please. Alright, 6, 49, and 8. There is no greatest common factor among those numbers, and we don't have a k in each one. So we're just going to use the AC method. 6 times 8 is 48. And factors of 48 are 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. All right, do any of these add or subtract 49? Yes. Now, I had these to begin with, and why did I keep going? Because sometimes there will be two possibilities. So I want to list all the factors just to make sure that I have every possibility. All right, we want this to become negative 49. The only way that this 1k and this 48k is going to become a negative 49k is if they are both negative. So we're going to expand that term. 6k squared is going to stay as it is, and the 8 is going to stay as it is. But we're going to rewrite it as negative 1k and negative 48k. We've expanded the middle term. Now we're going to factor the first two. First two, I can take a k out, and I'm left with 6k minus 1. The second one, I can take an 8 out. But if I take a positive 8 out, then I'm left with a negative 6k. And I want it to be the same, so that means I'm going to take out a negative, becomes plus 6k minus 1. Now the things in parentheses are the same, so 6k minus 1 and k minus 8. That is the factored form. Alright, so this one we're going to use the AC method, but once again we want to check for greatest common factor. So we have 36 and 36. So let's do 30. We have 1 and 30, 2 and 15, 3 and 10, 5 and 6. Ooh, that's great because we have 6 and we know our factors are 1 and 6, 2 and 3. So if 36 is divisible by 6, we can take out a 6. Which if we do 36 divided by 6, totally works. So we're going to take out a 6, and we have n squared n, no n. We can't take out a variable. But if we take out the 6, we're left with 5n squared minus n minus 6. Alright, this is going to be like the one we did with guess and check. We're going to leave this 6 out front because it's still part of our factor. We still want to write it so that we can get back to the original expression if we need to. So we need to include this 6, but we want to make sure that it kind of stays separate from what we're about to do with the 5n squared minus n minus 6. Oops. So I'm going to put a bracket, and that just gives me an extra layer, and that also means that I can put parentheses inside of it because I'm going to need to. Alright, so we have a 5 and a 6 here, so that means we're going to use the AC method because guess and check would just have too many options. So 5 times 6 is 30. Remember, it's called the AC method because you multiply A times C. And then you get 2 and 15, 3 and 10. Oh my gosh, I just did it up here. Why am I doing it again? Alright. I'm losing it, y'all. Alright, do any of these add or subtract to get 1? Yeah, these do. So how are we going to get a negative 1n out of this? If we have a 5 and a 6, and they're both n's, let me rewrite this. We know it's going to be 5 and 6, and we know it's going to be 5n and 6n, and we want it to be equal to a negative 1n. The only way that's going to happen is if this 6 is negative and the 5 is positive. Because if we had the 5 be negative and this be negative, then be negative 11, that would work. If we had the 5 be negative and this be positive, it would be positive 1n, that won't work. And if they were both positive, it would be positive 11n. So the only way we can expand this term so that it'll give us a negative 1n is by having a positive 5n and a negative 6n. So I'm going to rewrite it down here so we have lots of space. 5n squared, remember the first and last term just get rewritten again, minus 6n minus 6. And I do want to draw your attention to the fact that it does not matter what order you write these in. So if I put negative 6n and 5n, I'm still going to end up with the correct factors. It's magic, well, except it's not, it's math. But we're still going to factor out the same things, so just have faith. Alright, so let's look at the factor for the first two. I'm going to rewrite my 6, and now I'm going to put in parentheses, so this bracket's going to be really important. I can take out a 5n from both of them, and I'm left with an n plus 1. I can take a negative 6 out of the second two, and I'm left with n plus 1 again. So notice they have the n plus 1 in common. I'm going to write the 6 again, and I can write, and I can use just parentheses now because I know what's going to be in the binomials. I have n plus 1, and then what's left is 5n minus 6. This is the fully factored form of this expression. We can't leave out the 6, can't leave out any of the binomials, because otherwise we wouldn't get back to the original expression. Alright, go ahead and pause the video and try this one on your own. Alright, the greatest common factor of 24, 30, and 6 is 6. So we can take a 6 out, and we're left with 4b squared plus 5b plus 1. And this is great because instead of using the AC method with 24 and 6, we just have to use 4. Factors of 4 are pretty easy. 1 and 4, 2 and 2. So we're going to expand the middle term using 4 and 1, because that will make 5. And we want a positive 5, so that means they're both going to be positive. That's how we would add them together to get a positive 5b. So I'm going to rewrite the middle term. 4b squared plus b plus 4b plus 1. And then we're going to factor the first two by grouping. Oops, excuse me, I'm sorry. And if you did these in a different order, so if you did 4b first and then b, you're still going to get the same answer because it's still going to factor the same way. So it may not look the same in the middle steps, but at the end it should look the same. So we can take a b out. Oops. My bad. Okay, we can take a b out, and we're left with 4b plus 1. And 4b plus 1, we can't take anything out of this, we can just take a 1. And we get 4b plus 1. Okay, so the 6 gets written again, and we have a 4b plus 1 in common, so we can take that out and write it. And then we have a b plus 1 that's left over. So the fully factored form of this expression is 6 times the quantity 4b plus 1 plus b plus 1.